try to now apply arithmetic concept, geometry concept into probability topic, right? So here what we learned is that probability conventionally it is favorable outcome upon total number of outcomes. In normal question we'll be able to count the favorable cases and total cases, right? However, there could be cases where favorable is nothing but a distance in terms of line, or favorable is nothing but an area, right? So these were the two questions we did. This was an example of area as a favorable case, and before this we did this particular question where length was the favorable topic, right? So continuing the same pattern, try this question. I'll give you 2 minutes to try and then we'll discuss it. So see what is given in this. Maybe let me ask some of you who has attempted it. How did you solve it? Aslam, can you unmute and answer? How did you solve this?
Yes. So there are like 3 time slots in each hour.
Okay.
Like 20 minutes each if you are taking. So when we are taking 3, there are 2 hours in between 5 and 7. So there will be totally 6 slots. So the first person can come anytime between. So the first person can come in any of the 6 slots, and second person also can come in any of the 6 slots. So there is a total of 36 possibilities, and out of which both of them coming together is 6. So 6 by 36 is 1 by 6.
No, so you're solving it like this, right? That between 5 to 6 you have 3 slots. But why 3 slots? Okay, like they can come anytime, right?
Between 5 to 7 there are 6 slots. Total
Correct.
6.
Correct. Then
and out of it, like the first person can come in any of the 6 slots. So he can come in any of the 6, and the second person also can come in any of the 6 slots. And if they're waiting, they'll be waiting for 20 minutes each.
Got it. Okay.
So what I
See,
took is
one catch here, Aslam, is, say for example, the first guy has come in this slot, right? This is slot number 2. For example, he was coming at 5:30.
okay.
Okay. Now see, second person can also come in the third slot. For example, 5:45. Even gap between these two is only 15 minutes, right?
Understood. Okay, I haven't considered that. Yeah.
Same goes for here. This guy can also come in this first slot, 5:15. And again, he'll be able to meet the second guy. Okay. So
Okay.
this is why what you did would not work here.
Okay.
Cool. So with this, let's at least see whenever there is a continuous graph, right? So just maybe take it as a hint that wherever there is a continuous graph, and continuous graph is 5 p.m. to 7 p.m. is like a continuous number. It's not like a discrete graph where you have some specific values. It could be anything. 5:01, 5:02, 5 minute, 5 hour, 1 minute and 30 seconds. So because values could be anything, nothing is mentioned, you get a hint that either this question would be solvable using area or using line, similar to what we did in the last 2 examples. So here can I say that, okay, I have 2 guys, right? First person is A, second person is B. So from here, you should have gotten a sense that it's going to be some, like, a 2-dimension thing. So I'll try to say that, okay, this is the guy A, this is the guy B, right? And I will consider 5:00 p.m., 5 p.m. as this particular point, as the starting point, right? Now, A, how many minutes does A have? Because they coincide in terms of minutes, I'll compare that. Okay, they can come anytime from 5 p.m. to 7 p.m. So in total, how many minutes do each of them have? If I come at 5 p.m., the maximum I can come is till 7 p.m. So in total, there are 2 hours of distance. That is my sample set, right? So in total, A can come anytime in 120 minutes. Why 120 minutes? Because if I consider 5 p.m. as the starting origin, I have 2 hours ka difference, right? Where A can come. Similarly, B can also come anytime in this 120 minutes, right? So total, B can come after 1 minute, 5 minute, 10 minute, 90 minutes, 100 minutes, or 120 minutes. Similarly, A can also come anytime between 0 to 120. Now I know for a fact, let's say A is nothing but A is essentially minutes after 5 p.m. when A comes, right? So I am defining this particular axis A as that after 5 p.m., after how many minutes does A come? Okay. Similarly, I'll consider B that okay, B is say यार 5 बजे के बाद B कब आता है? That number of minutes is nothing but my y-axis, which is B. So for example, if B comes at 6, right, it implies my value will be 60 minutes because it is 60 minutes after 5 p.m. Similarly, if A comes at 5:30, the value for E will be 30 minutes, right? Now the only constraint I have is each will wait for other for 20 minutes, right? So if I want them to meet, what should be the constraint between A and B? Just think for 15-20 seconds, what is going to be the constraint between A and B if they have to meet? Okay, Dhruv says A minus B should be less than 20. Other 19 students?
The mod of A minus B is less than equal to 20.
Okay, good. Dhruv, you said A minus B, but it could also be B minus A, right? Because whosoever comes first, the other person has to come within 20 minutes of that, right? So I know that the difference between the timing when they are coming, right? The difference between the timing when they're coming, A minus B, its modulus has to be less than or like less than equals to 20 minutes. This is my favorable region. Correct? If this condition satisfies, then they are definitely going to meet. And my total is what? Total is nothing but A less than equals to 120 and B less than equals to 120. Is everyone clear with these two equations? That this is my favorable case if they have to meet, and this is my total cases. Just react if this particular line is clear. Yeah, Chinmay.
No, sorry. I was just reacting thumbs up.
Perfect.
Mistakenly.
This was the crux of such difficult questions. So if this is clear, what is going to be my total region? Then this is a question of graphs, right? That okay, total is this 120, 120. So this particular square is my total, right? By this particular square, because यहाँ पे A is less than 120, नीचे B is less than 120, right? So this entire area, this entire square is my total region. Now, how do you draw the graph of mod of A minus B less than equals to 120? Of course, this is going to be two parallel lines, which says कि जब A की value 0 है, then B has to be less than 20, right? So, is this the right graph here? Drawing is not that great, but yeah. This is that line which says B is B minus A less than 20 and A minus B less than 20, right? This is mod. So this is nothing but B is less than equals to 20 plus A. So if this is A, this is going to be that line. Similarly, the second parallel line is going to be like this, which comes somewhere from here, right? And this will intersect again. Again, these are going to be the straight lines, right? So that, and these will be the parallel lines, right? So B can be anytime within this, and so this becomes my favorable region, right? Again, it's simply the graph of this particular line, right? You can even figure out that when A is 0, B has to be less than equals to 20, right? So this entire region, when A is 1, B has to be less than equals to 21, right? So this is B21. Hence, this line comes if you just plot the linear points. Similarly, this line will come if you reverse it. Okay. So my favorable region is nothing but this particular area. This area. Again, is everyone clear? How did I draw these two parallel lines? Any doubts here? No? Perfect. So this is clear. My probability is what? Probability is favorable upon total, right? Favorable is this particular area upon total. The total to kitna hai? Total is going to be square ka area 120 into 120, right? And favorable is this. How do I find the area of this? The best thing is total minus these two triangles, right? By symmetry, these two triangles ka area is going to be same. So total kitna hai? Total is 120 into 120 minus two triangles. So 2 into, these are right angle triangles, half into length into breadth, half into base into height. What is this base? When this is 0, this is 20. Similarly, this is nothing but 20, right? So in total, this length is going to be 100 and this height is also going to be 100, right? You can check the graph again. So the area of this triangle is half into 100 into 100. You solve this, you will get 11 by 36 as your answer. Exactly the same answer that Raman pointed out. Clear? A very advanced, different type of question from probability. But now if you look back on similar question, you should be able to solve it within a minute. It's simple, right? 5, 7, 120, 120. And then this particular graph of two parallel lines. All this is needed to crack this question. Everyone clear? How do you solve such questions? Again, I'm reiterating, you would see these questions in your mocks. So now I want all of you to go and attempt this, not just mark the answer 11 by 36, but go and solve it in the mocks and then feel confident about solving a difficult question. Perfect. So with this, let's move on to a new concept, right? This is essentially a new lingo that is used in a couple of questions of probability. The lingo is odds for or odds against, right? This is essentially how do we apply the concept of ratios and probability. So for example, if question says, all you have to be careful about in this question is how do you decode the language. So the language is if odds for A winning is 2:3, right? If this is a particular statement that is given, I want you guys to be able to figure out that this is nothing but odds for A winning. Because this is winning, the first number that is mentioned corresponds to A winning, right? And the second number that is mentioned is it corresponds to A losing, which is opposite of A, right? So simply, if you now have to calculate the probability of A winning, probability of A winning is, this is going to be my numerator favorable case upon total number of cases. This is winning, this is losing, so total is 5. So probability of A winning is 2 by 5. Similarly, if I ask you probability of A losing is, this is winning, this is losing. So I'll have losing on the numerator 3 upon total, which is 5. So, fair. So the line that is given here is odds for A winning is 2:3. It implies that A would win in 2 cases and A would not win in 3 cases. So if you have to calculate the probability of A, you can derive it from here that this is nothing but 2 upon 2 plus 3. A wins in 2 cases, A does not win in 3 cases, so total number of cases is 5. Out of 5 cases, A wins in 2, so probability is 40%.
Okay.
Similarly, probability of A losing is 60%. Similarly, this question is probability against B winning is, so this is against B winning, which implies B losing. Hence, the first number is for B losing. So if I have to calculate the probability of B losing, it is nothing but 1 upon 1 plus 5. Similarly, probability of B winning will be 4 upon 1 plus 5. Similarly, next question, odds against C losing. Against C losing का क्या मतलब हुआ? C winning. It implies probability of C winning will be 1 by 5 and probability of C losing will be 4 by 5. So if this question comes in that, language that will be given as odds for A winning is 2:3, odds against B winning is this, and odds against C winning is this. अब यहाँ से these are the 4 questions that would come in CAT. So start solving it. Now it should be very straightforward for you guys. Simple probability question, right? So first is easy, right? Probability that all win. A win into B win into C win. A win कितना है? 2 by 5. B winning is 4 by 5. C winning is 1 by 5. So you just multiply all of it. Answer will be 8 by 125. Second question, probability that all lose. A lose into B lose into C lose. Right? C part, probability that at least one of them wins. At least one. See, या तो subjective method करोगे. Here exactly 1 wins plus exactly 2 wins plus all 3 wins. That's going to be very longer, right? So what we'll do is probability that at least one win is 1 minus probability that no one wins. Right? Probability that no one wins is nothing but probability that everyone loses, which is answer of B. So answer of C will be 1 minus B. Clear? Then D question, probability that exactly one wins. अभी exactly one में you'll have to take cases यार सिर्फ A जीत रहा है. So सिर्फ A जीत रहा है इसका मतलब A wins, B loses, C loses plus B wins, A loses, C loses plus C wins, A loses, B loses. So you have all the numbers. Just plug the numbers here and you'll get your answer. to solve this one. A is starting the game. The game says whoever throws 6 first, he will win. What is the probability that A wins and what is the probability that B wins? This is the application of sequence and series. Maximum 30 seconds. Nope, still not. Okay. Let me ask Rupal. कैसे किया?
So couldn't understand.
Sorry.
Didn't got it.
Why? How were you trying it?
Sir, I was making cases about if A will get one first,
ठीक है
then B
बताओ.
will try.
Cases बताओ. Let's talk about probability that A wins. A कब जीतेगा? And A is starting the game.
So first chance पे भी जीत सकता है.
ठीक है. तो probability is यार A ने start किया and A के पास सीधा 6 आ गया. Then A wins, right?
Yes, sir.
ठीक है. Let's say P is probability of 6, right? So ठीक है. और अगर 6 नहीं आया तो
So 6 नहीं आया तो B try करेगा, B का 6 आ सकता है.
probability of A not 6. हाँ. फिर
Then sir, then A can get again 6.
तो यू आर सेइंग कि अगर B ट्राई करता है तो B का 6 आ गया तो
So sir B जीत जाएगा.
ठीक है. तो अगर मुझे A को जिताना है तो B के 6 नहीं आना चाहिए.
Yes sir, B not 6.
ठीक है. एंड देन थर्ड में A
Then
का
sir
6,
A 6.
राइट. ठीक है. देन सो
Then
ऑन एंड सो
B
फोर्थ.
not 6.
फेयर. सो ये तुम्हारा क्या बन गया? प्रोबेबिलिटी ऑफ A 6. A के 6 आने की प्रोबेबिलिटी कितनी? 1/6 प्लस
1/6.
A के 6 नहीं आया, इट इज 5/6. B के भी 6 नहीं आया, 5/6. A के 6 आ गया, 1/6 प्लस सिमिलरली A का 6 नहीं आया, B का नहीं आया, फिर A का नहीं आया, फिर B का नहीं आया, फिर A का आ गया. तो यहाँ से ये पैटर्न दिख रहा है 5/6 to the power 4 into 1/6 and so on and so forth. This is nothing but an infinite GP. I can take 1/6 common. क्या बन गया ये? 1 plus 5/6 square plus 5/6 to the power 4 and so on and so forth. This is my infinite GP. Infinite GP का फॉर्मूला क्या होता है? A upon 1 minus R. A is 1 minus R. What is R? 5/6 square, which is nothing but 25/36. What is this? 36/11. So your final answer is 1/6 into 36/11, nothing but 6/11. In quant, you will never see a question only from one concept. Hence, it's important to cover every topic and apply cross-functional knowledge. But ठीक है. Is this clear to everyone? Good. So this was the first question. Similarly, probability of A winning is 6/11, so B has to be 5/11, right? 1 minus probability of A winning. Alternatively, if I had to write the expression for B, what would that expression be? If B has to win, A is starting, so A can't have 6. What is the probability that A can't have 6? 5/6. And then B has to have 6. 1/6. Plus A not having 6. B not having 6. Again, A not having 6 and then B having 6. And so on and so forth. So, the expression बन गया 5/36 कॉमन ले लिया मैंने. Same 1/5/6 whole square. This will be infinite GP. You solve it, you will get 5/11 as your answer. Okay. See, you have to consider all the cases, right? तो अगर A ने शुरू किया, what is the probability A gets 6? It is 1/6. तो अगर उसका 1/6 आ गया तो ठीक है. But अगर 6 नहीं आया, then what? Then can A ever win? या तो तुम बोलो कि यार अगर 6 नहीं आया तो A कभी भी नहीं जीतेगा. Then answer would be 1/6. But he has a chance to win again.
Okay. So if that
So
case
you will
would
have
have
to
been
consider
first go में
all the
ही इनको जितना है तो वो सारे cases नहीं आते थे.
correct.
Okay, got it.
अगर क्वेश्चन ये होता कि यार फर्स्ट चांस में A जीत जाए तब तो स्ट्रेट फॉरवर्ड है 1/6 आंसर हो गया.
Yeah, got it.
Right? Okay, so let's move on to the next interesting concept,
Sir, in this previous question, suppose the last statement is not given, A starts the game. So what, we will take half
Then you
and
can't solve it. Then you can't solve it. Answer will be cannot be determined on none of these.
so we can't take like selecting half A and B, we will select half and then
No, yeah. Usually, see, because you have to calculate the probability, probability will always be higher for the person who starts the game. So, see, you can take that half if if a line is given in the question that either of A or B can start the game. If a line like that is given, ki the person to start the game is chosen randomly, then you can take that half wala expression. But if nothing is given, if this is the only question, then you can do that.
okay, sir.
Moving on to the next concept, Bayes theorem. Super important thing. Questions in CAT from probability have come from this topic majorly. So pay attention. Can anyone explain me what is Bayes theorem? So essentially, see, until now we were solving all the things independently, right? But if question says, ki, yeah. So for example, what is the probability that match gets drawn between two person, right? Say if like a cricket match is happening, what is the probability that the match gets drawn? Versus given it is raining, what is the probability that the match gets drawn between two persons? So the answers change. So Bayes theorem is nothing but whenever in exam or whenever in question, if it is given, ki what is the probability of event A happening given B has already happened, then you apply Bayes theorem. So this particular expression of A pipe B, right? This is nothing but either you can write it as A by B or A pipe B. This says what is the probability of A happening given B has already happened. Okay. So what Bayes theorem tells you is the probability of event A happening given B has already happened into probability of B happening is equals to इसका उल्टा कि probability of B happening given A has already happened into probability of A. Right? The way to remember this is जो नीचे denominator में आता है that is the term you multiply it with. So if B is in the denominator, you multiply it with B. If A is in the denominator, you multiply it with A. So this is how you can remember this particular Bayes theorem. Right? This is what this particular theorem says. Given A and B are dependent, so given B, the probability of A into probability of B individually is equals to probability of A B given A into probability of A. Okay, just note down this particular theorem and then let's learn from questions on how do we apply it. First question, I'll solve it for you. First question says box 1 contains 3 white and 2 black, right? So say this is box 1, this is my box 2, I have white and black balls. So this is white balls, this is black balls, right? So white balls are 3 in box 1 and this is 2, this is 1, this is 4, right? Now, the question says a ball is picked from one of the two boxes. Okay, a ball is picked from one of the two boxes. It turns out to be black. Okay. So find the probability that it was drawn from box 1. Now, what does my question say? Question कह रहा है कि यार what is the probability that the ball that came out to be black is from box 1, right? So a question is nothing but probability of box 1 given that the ball that was drawn was black. So this is how you try to. So यहाँ पे it's very important to understand कि equation में क्या पूछा है. So like equation is not saying probability of black, sorry, probability of box 1. It is saying कि यार black निकला है अभी जो बॉल को मैंने उठाया था, तो क्या probability कि वो मैंने box 1 से निकाली है. Okay. So maybe at least give 30 seconds to yourself to digest this, to try this question, and then let's discuss it. Cool. So let's look at this question. Okay. See, पहले तो तुमको ये निकालना पड़ेगा ना कि ये black ball आने का probability कितना है, right? Because in total what you have 5 white balls and you have 6 black balls, right? So it's not कि you can simply say 6 by 11, right? Because we have a 2-dimension thing, white and black and box 1 and box 2. So how do we do such question? Just a minute, I'm getting a call. Yeah. So the best way to do this is write this expression. This is the simple formula that I've applied, right? Isko ulta kar diya, black by B1 into B1, right? Now let's try to find the answers. So probability of black given B1. अभी अगर ये given है कि मेरे को box 1 से निकालना है, तो क्या probability हो गई black की? Everyone tell me.
2/5.
2/5, right? Now तो it's like rocket science की एक ही box है, उसमें 3 white ball है, 2 black ball है. So what is the probability of black ball? It is nothing but 2/5. So this is first expression is 2/5. Second is क्या probability है कि मैं box 1 से निकालूंगा? I have two
1/2.
1/2. दो boxes है, दोनों randomly मेरे को choose करने हैं. A ball is picked from one of the two boxes, so it is 1/2 divided by probability of black. Now again, probability of black will depend on whether I'm picking it from box 1 or box 2. So what is the probability of picking it from box 1? So probability of black is nothing but probability of box 1, which is 1/2, into, given it is a box 1, what is the probability of black? 2/5, plus probability of box 2. Now given it is a box 2, what is the probability of it to be black? 4/5. To solve this, you will get your answer. Right? So 1/2 gets cancelled. 5 gets cancelled. 2/6. The answer is 1/3. So yeah, moving on to the next question. Solve this. Sneha is known to speak the truth in 75% of the cases. Okay. She selects a natural number from 1 to 10 at random and says that it is a prime number. What is the probability that the number selected is actually a prime number? So again, base lagega. Probability that the number selected is a prime number, given she is saying that it is a prime number. Rachel, batao, how did you solve it?
So, sir, for telling the truth, the probability is 3/4.
Correct.
And out of 1 to 10 numbers, we are having 4 prime numbers.
Correct.
So 3/4 into 4/10. This will be the numerator.
Why? Okay. So the probability of the number selected is actually a prime.
Yeah. So the probability of prime into the probability of telling truth. So 3/4 into 4/10.
So the number is actually a prime into probability of
Telling truth.
okay.
And the denominator will be this prime and truth, and lie and non-prime. So this will be 3/4 into 4/10, and in a numerator and the denominator will be 3/4 into 4/10 plus 1/4 into 6/10.
Okay, perfect. Cool. So everyone, I think what Prajwal was explaining was the right method. See, यहाँ पे एक पूछा क्या है? What is asked to you is probability that the number selected is prime, given that what she has spoken is that this is a prime number, right? Sneha has spoken this to be a prime number. So what is this? This is nothing but probability of E by A into probability that Sneha speaks prime. Right? So essentially probability that Sneha, like whatever Sneha speaks is actually a prime number. I don't know how to write it here, but yeah, I'm just trying to apply Bayes theorem here, right? So into probability that Sneha speaks prime, given it is actually a prime number, into probability of prime number, right? So this is how the expression that Prajwal mentioned comes out. So given, so first of all, what is the probability of a prime number? We have 10 numbers, right? Out of 10, 4 numbers are prime, 2, 3, 4, 7. So this number we know is nothing but 4/10. Similarly, if the number is actually a prime, what is the probability that Sneha speaks prime or speaks truth? Right? What is this? कि अगर सही में prime number होगा, तो we know कि Sneha 75% सच बोलती है. Okay. So what is this number? This is nothing but 3/4 because 75% of the times she will speak truth. So given the number is prime, Sneha, 3/4 cases mein she will speak that the number is prime, right? So this becomes my numerator. Abhi mujhe denominator lana hai. So by default, this is my favorable case, right? So abhi denominator mein mujhe kya leke aana hai? I have to bring total number of cases because this is probability ka question. So denominator mein it is like what is the probability that Sneha actually goes and speaks prime number, right? If she is saying prime number, what is the chances that actually it is a prime number? So probability of she speaking the truth into actually it is a prime number, which is my numerator. Again, if you just look by observation, right, you will start learning this by itself. If this is my favorable cases, my total number of cases kitna hoga? Favorable 3/4 into 4/10 plus iska exactly ulta, because denominator always has to be favorable plus unfavorable, right? So if this is 3/4, what is the probability she does not speak truth into when she does not speak truth? What is the probability of having a non-prime number? It is 6/10. So just by observation, you can also start writing with practice ki in Bayes theorem, you can simply apply. एक बार तुमने numerator लिख लिया, then denominator लिखना is not difficult. It is favorable plus इसका exactly inverse ले लो. So 3/4 का inverse is 1/4 and 4/10 का inverse is 6/10. You just solve it. I think you will get 2/3 as the answer. I think I have to use better terms here. Can anyone help me? How do I use the notation here? Let's consider that this is nothing but probability that Sneha says that it is a prime number, right? So it is Sneha agar truth carry into prime number plus Sneha agar galat carry into prime number. So denominator is actually mein Sneha jo carry hai wo prime number hai ya nahi hai. That is what is my denominator. Now, how do I write it in terms of words? I don't know, but yeah, like this is the gist.
So we can say that in denominator it is always whatever Sneha is saying, it is what is the probability that we have a prime number? In denominator it is that.
But probability of prime number is this, right? 4/10.
In denominator.
Yeah.
So it will be the total probability, na? Ki whatever, irrespective whatever Sneha will say, we will have a prime number.
Correct.
So this is the total probability, and what we need to find is that actually Sneha is telling the truth. So we'll find it in respective of Sneha saying the truth, basically.
हाँ, correct. Like Chinmay, तुमको ये समझा क्या? It's slightly harder for me to explain this क्योंकि थोड़ा सा verbose question है. But are you sort of getting the gist here? What is it in the denominator? It is Sneha saying prime and it is actually prime into Sneha saying कि यार ये prime नहीं है और वो prime नहीं है. So if we multiply that, it actually turns out to be negative into negative is positive.
Yeah, that's what I said. No, it is just about truth. I mean, if she's saying prime, it could be prime, and if she's saying it's non-prime, it should be non-prime. So it's
Correct.
actually about truth, that Sneha is saying true things. That's what
Correct.
we have in denominator. Okay.
Correct.
Okay.
So alternatively, if you don't have to apply Bayes theorem and all, right, you can also simply say that probability that the number selected is actually a prime via Sneha, right? So Sneha saying here it is a prime number into it is actually a prime division by total cases. Here prime एक कब हो सकता है कि Sneha prime बोल रही है तब prime है plus Sneha जब prime नहीं कर रही तब भी non prime हो सकता है, right? So that becomes my total case. मुझे सिर्फ एक case का probability मिलती है. So one way is you apply Bayes theorem. Second is you also think it directly and just write this expression. So similar to what Chinmay you are saying, right? कि हम लोग ये expression को directly भी लिख सकते हैं.
Yeah, getting it.
Aligned. So I think a couple of more questions we'll need on Bayes theorem so that we master this concept. It's slightly confusing. It's all about how well do you write the expression.